Just a young gun with a quick fuse.
Okay, let's continue with the next part 3. Okay, this one we have chapter 4. If you study the learning outcome, first we need to describe the formation, a few bonds such as ionic, covalent, dative, draw the Lewis structure. We have single, double, triple. We have to determine formal charge, most possible Lewis structure. Explain exception octet rule. We have incomplete, expanded octet, and odd number electron. Illustrate the concept resonance, and then predict explain shape of molecule and bond angle in given species. Right, for this example, I will discuss with you the shape of molecule, bond angle so far, and then at the same time, when we try to discuss the shape, at the same time, we try to draw using the formation of covalent, draw the Lewis structure, at the same time. Okay, take a look at the example. For sample oxygen trifluoride, okay, we need to determine the molecular geometry of molecule and explain. Okay, the first step, we need to calculate the number of electron oxygen, number electron of fluorine, and distribute the formation of bonding, distribute to the electron to the terminal. Okay, alright, this one example. We have a structure OF2, which have a 2 lone pair with 2 bonding pair. Alright, so 1, 2, 3, 4. We have AB4, which is AB2E2. Okay, so we have 4 electron pair. We have 2 bonding pair electron with 2 lone pair. So AX2E2 or AB2E2. Basic shape tetrahedral. But we have lone pair, repulsion between lone pair. Okay, repulsion between lone pair, bond pair. Repulsion between bonding pair. The repulsion will reduce the bond angle. Okay, alright, so according by valence share electron pair repulsion, okay, because result of repulsion reduce bond angle. So next one, the molecular shape should be V shape or band. Alright, so as the exercise, what the basic shape, what the molecular shape for OF2. So the basic shape tetrahedral. The molecular shape was V shape or band. Alright. So, okay, for the next one, we try to take a look at the relationship by hybridization. So far, I think you're quite familiar. We have 5 types of hybridization. sp3, sp2, sp, sp3d, sp3d2. Right? So, according by example, take a look. We have IF4 positive, does not obey the octet rule, right? Show the orbital diagram for the center atom, alright, in the ground state and excited state. Show the hybridization that occur to represent overlapping, alright, with the orbital of the terminal atom, alright, and using valence share electron pair repulsion, show how the geometry of the species can be determined. Sketch it geometry, that one also cover for molecular geometry learning outcome. This one also example previous PSPM question. Okay, so take a look at the step. You need to draw the structure. Second one, calculate formal charge. Next one, orbital diagram for valence electron for the center atom. We also consider formal charge for ground state, and then excited state, number of single electron in orbital equal to number of covalent bond, which is sigma and pi. Hybridized state, number of sigma and number of lone pair. And then next step, we have types, identify types of hybridization. And next one's valence electronic configuration for terminal atom. And we proceed to orbital overlapping diagram. Alright. So take a look at first step. To draw the Lewis structure, we need to total the number of valence electron. Okay, form the bonding within. Okay. Right now we have 2, 4, C8. Okay, that's why minus 8 electron. 26 electron we distribute to the terminal. Total number for terminal 24. So balance 2 electron. 2 electron to the center atom. Alright, 2. Right, take a look. If you try to simplify, so how to calculate the formal charge. Iodine, we have 7 electron valence. So 1, 2, 3, 4, 5, 6. In this case, 1, 2, 3, 4, 5, 6. 7 minus with 6, we have positive 1. That's why formal charge is positive 1. Okay, but for fluorine, 1, 2, 3, 4, 5, 6, 7. 7 minus 7. 7 electron valence for fluorine. minus with 7 electron. Okay, right now we have a total number of 7. That's why equal to 0. And then to discuss for the ground state, excited state, okay. And this one hybridized state. So far this one hybridized state. Alright. Okay, so first, okay, iodine positive equal to, okay, 6 electron. Alright, so that's why we just need 1, 2, 3, 4, 5, 6 electron here. Alright, so first, as usual, for electrovalence, we need to, okay, complete 5s followed by 5p. Okay, alright. And then we have excited for 5p, excited 1 electron. Okay, because if you study the Lewis structure, we have 1 lone pair, 4 single bond. Alright, single, 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 or sigma, 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 sigma. So 1 lone pair. So we just only have 1 lone pair. Okay, to form sigma or single ada 4 single. So we need to excited ones of electron at orbital pi p, jump 1 electron. Okay, so we have 1 lone pair, 4 single, which means 4 sigma. Alright, okay, this one. Okay, 1, 2, 3, 4, 5. And this one must be a correction. Make a correction. This one, this This one should be single. Single, single, single. Right. So 1, 2, 3, 4, 5. We have sp3d. Okay, if you try to calculate 1 plus 3 plus 1. That's why types of hybridization sp3d. Right. So for terminal atom. Alright, chlorine 7. We have 1, 2, 3, 4, 5, 6, 7. This one we overlap after this. Okay. So drawing orbital overlapping diagram. Alright, so sketch sp3d. Okay. So we have trigonal bipyramidal. Okay, shape in the trigonal pyramidal. Alright. Okay, take a look. The basic shape was trigonal bipyramidal. Right. Complete with the pair of electron. Right, it's 1 lone pair. Okay, please cancel this one right, twice. Okay, and then label sigma. Okay, then bracket to mention the charge. Okay, alright, label pi if any. Okay, in this case no pi. Right. Okay, to explain, we must mention iodine, hybridization iodine atom sp3d, which is overlapping of what? Okay, overlap with 2p orbital of fluorine to the 4 sigma bond. Consists 1 lone pair. This one if you try to explain. To discuss molecular geometry, alright. So just if you observe, we have 5 electron pair around the center atom of iodine. So the basic molecular geometry should be trigonal bipyramidal. Okay, and you also can observe from the structure, from the Lewis structure. Alright, okay, from the structure actually, right, we have 4 bonding pair and 1 lone pair. Okay, using valence share, pair electron repulsion, we have repulsion between lone pair, bonding pair, bonding pair, bonding pair. The repulsion reduce the bond angle. So as the result right now, we have molecular geometry seesaw. So in this case, we don't have lone pair repulsion. Right? Okay. For the next one, we have explain factor that flow influence when the wall forces and hydrogen bonding. Right? We have relate the effect of hydrogen bonding for the physical properties such as boiling point, solubility, density of water compared to the ice. The very favorite question. Okay, can you identify which one higher boiling point? So if you take a look at example discussion, okay, intermolecular forces directly proportional to the boiling point. Alright, so in the sample we have propane, dimethyl ether, ethanol, ethanoic acid. We can identify propane with van der Waals forces, London forces, dimethyl ether also with van der Waals forces. Okay, but we have dipole forces. Ethanol have hydrogen bonding. Ethanoic acid was more hydrogen bonding. So we already know, hydrogen bonding is stronger intermolecular forces between dipole forces. So in this case, ethanoic acid was the higher boiling point, followed by ethanol, followed by dimethyl ether, followed by propane. This one actually example that mentioned by sequence. That we have the less than. Okay, so sequence mentioned using symbol greater or smaller than. If commas used, show the direction of sequence by using arrow. But for explanation, just to share tip for explanation, must include all the key facts. Do not repeat the same or similar fact. Focus on the question, need point asked, use correct term. Can answer in point form but use complete sentence. For another example, the previous PSPM talk about polarity, discuss about BF3, discuss about NF3, okay. So for BF3, we observe right now the BF bond is polar, because chlorine have a different electronegativity with boron, or more electronegative with boron, Bond dipole are equal magnitude. Symmetrical arrange, we have diagonal planar. So the bond dipole can cancel each other. The next dipole moment mu equal to 0. CO2 non-polar molecule. Right? So take a look at F3 after you draw the Lewis structure. We have a lone pair. Alright. So NF was polar and F bond was polar because have different electronegativity, which is fluorine is more electronegativity than nitrogen. Right? Bond dipole unsymmetrical arranged. We have diagonal pyramidal equal in magnitude. Alright. So bond dipole cannot cancel each other. Mu not equal to 0. This one, ammonia was polar molecule. Alright. So next one, we have relate metallic bond, for malleability, ductility, electrical conductivity, thermal conductivity, and then also relate by boiling, melting, for the molecular structure, types bonding, intermolecular force, for period 3, group 1 and group 17, for your syllabus. Alright, so take a look, why we have the variance, or we have the different number of melting point, alright, such as, represented by sodium, magnesium, aluminium. We study about the metallic bonding, which is strong electrostatic force of attraction between positively charged ion with the negatively charged delocalized of electron. Alright, a lot of electron needed to overcome attraction. In the silicon, very high, alright, we have giant covalent lattice, strong covalent bond. Lots of energy needed to break, okay? But within phosphorus, sulfur, chlorine, argon, we have simple molecular structure with intermolecular forces between molecules, little energy needed to break the forces. Last one, electron C model, mention the positively charged with electrostatic force with the delocalized C of electron. That C electron can mention free electron, delocalized electron, and also mobile electron can conduct electrical. That's all. We'll be continuous for the next part. Thank you.
Just a young gun with a quick fuse. I was uptight,